Let's prove that the derivative with respect to x of sine of x is equal to cosine of x. Whenever we're working with these trig functions, we are assuming they are in radians. So limit definition, if I'm trying to find the derivative of sine, it's going to be the limit as h goes to 0, sine of x plus h minus sine of x all over h. And let's go ahead and use the addition formula for sine to simplify the start of this. It's actually going to get worse before it gets better, but I'm trying to break up that x plus h if I can. So the addition formula says that I'm going to look at sine of the first term times cosine of the second term plus, and then mix it up. So I'm going to have sine of h and cosine of x. I'm going to give myself a little more space there. So I've got that crisscross going on. Sine of x, cosine of h, sine of h, cosine of x. That's the addition rule for sine. That's rewriting that first chunk of that derivative formula. And I can see some pieces of this that look kind of nice, but other pieces look like there still might be some things missing or going on. So let's see what we can do here. I'm looking at the limit as h goes to 0, sine of x cosine of h minus sine of x. Why don't we group together our sine of x stuff? There's a sine of x here. There's a sine of x here. Let's group and see if we can factor a bit. And this entire thing is over h. This leaves me with the limit as h goes to 0. Looks like both of those things have sine of x, so I'm going to factor out a sine of x. And then if I do that, I have cosine of h for that first piece, that one. And I've got just a -1 for that second one, -1 times sine, giving me the negative sign. And this is all over h. And I'm going to split my limit up. I'm also going to look at the limit as h goes to 0 of sine of h cosine of x over h. So there are two limits here that I really want to explore. This first one, I can pull that sine out. I have the limit as h goes to 0 of cosine h minus 1 all over h. And for this other piece, I have cosine of x times the limit as h goes to 0 of sine of h over h, just kind of factoring some pieces out. We've got two limits here that look a little bit messy. Let's pull up GeoGebra or Desmos and make a table and see what's going on here. Okay, I'm in Desmos and I typed in this cosine of x minus 1 over h, and I just want to zoom in at 0. And notice as I'm zooming in and in and in, it doesn't really matter because it looks like this thing is still getting really, really close to 0 for that first limit. So that's telling me over on the side here, this first limit, this piece is going to go to 0. Let's check out the sine piece. Zooming out here. Okay. I also was wondering what's going on with sine of x over x or sine of h over h as we get closer and closer to 0. And there it looks like it's approaching the value 1. I keep zooming in more and more and more. And the closer I get to x equals 0, my y value is getting really close to 1, even though it is technically undefined right at 0. So this tells me that this second limit was going to 1. So putting this all together here, we've got sine of x times 0, but anything times 0 is 0. So 0 plus cosine of x times 1. Multiplying by 1 isn't going to change much. Adding 0 is not going to change anything. The only piece that's left here is cosine of x. So the derivative of sine is cosine. If you do a similar process, but you use the addition rule for cosine, you should get that the derivative of cosine is negative sine. I'd encourage you to try that out here. It's going to be a very similar technique for finding that derivative, but we have established here derivative of sine, cosine. Let's check out more of these together.